So welcome everybody. Today we'll try to learn how to make your own custom hangers with Autodesk Revit generic model families. So first of all, we should start by just creating a new family using metric generic face-based template that comes with Revit software, Revit installation. Let's press open. So for comfortable start, we've created some elements that can be used for your quick hanger family development. So what we'll do at first is just upload some elements that we need for a particular hanger. Basically this family is a central family for our hanger assembly, and so the whole assembly is just a nested family that is done by creating relationships between different nested families inside this assembly family. So let's start by loading some families inside. I have a metric hanger parts folder with different separate elements, and there's some nested elements, set elements also for quicker use. So we can just click the thumbnails view so we can see what we have over here. We also have such parts for Imperial users, and this is done pretty easy. So now I will try to use the metric parts for that. And for this particular situation, I will need the suspension ring. So I will make the list for that. I will use the duct suspension ring with bolts. Then I will need threaded rod for that, and wet fix purlin. So let's upload these to my assembly family. And next thing we need to do is just arrange them in this particular family. So I will start with just putting my suspension ring into place. So let's drag it out and let's put it somewhere around the center of this family. And let's try, and I will just make my lines thinner, and let's align these to the reference planes that are drawn by default, and I will lock that to the center. So if we'll look in 3D view, we'll see that this is the family is inserted to the center by the center of offsetted by the center of its core. So what we need to do is just make a parameter that offsets this family to the top position of the bottom of the ring. So now I will create a parameter that just calculates the distance from center to that particular situation, which is half the diameter of the duct. So at first I would like to create the diameter parameter. So I'll just press add, and because there's the parameter data is different for different parameters that works in structure in smart hangers. So we created a shared parameter file, which we can find in our PC with the smart hangers installation. So I'll look at my C disk, then I'll go to program data, I'll find tools for Revit. These are all the installations of our software. So I will find smart hangers folder, and I will try to look for the shared parameter family in my metric library. So I'll open it up, and we have these parameters that we can use over here. So we have the diameter parameter here, so I will just press OK, and I will select the diameter parameter, and we can see that we have all the parameter data set. So there's another thing that is pretty much important, is that all the data from the parameter grouping is just set to work for different parts of the hanger, such as if we have a duct and as a host family. So for smart hangers to read the parameters from it, these parameters has to be grouped in model properties group. So I will set that as an instance, and I will speak about the grouping a lot more later. So I will just create this diameter function, this diameter parameter, and now I need to calculate the half of this length. So let's set diameter to 300 millimeters, and now let's add another one, which will be instance also, and I'll set it as suspension ring offset, and that will be my calculation of half the diameter. So I will press OK, and I will write in the formula diameter half of the diameter, and I'll press apply. So I'll go then to my suspension ring, and we have an offset parameter which will link with the suspension ring offset parameter. and I'll press OK. So we can see that it's there where we need it to be. So as we have the suspension ring in place, we can insert our threaded rod. So we'll go to reference level again, and just let's put this type of rod into our family. And now I will set that I will want to place it on work plane, and let's make sure that the work plane is reference level. So I'll put it somewhere over here, and then I will align it to center. Let's look at it in 3D view. So we have the situation where the bottom is below the suspension ring. So first off, we need, because the rod has these parameters, bottom extension and top extension, so we'll just make it 0. And if we'll look at it again, we'll see that the rod is straight on the reference level, and that's not very accurate because the length is a little bit less than this, so we'll need to offset it too. And I would recommend to create the parameter, which I call just 0, and it doesn't matter if it's type or instance. So I will make it instance, and I will just insert the 0 to the formula to lock it, and then I will create link the bottom extension formula with the 0 parameter. Another parameter I want to create is my rod offset, which is about 3 or 5 millimeters, depending on the thickness of the suspension ring. So I will create a parameter called suspension ring thickness. I will create it as an instance parameter, and will write the 5, 3 or 8 depending on your suspension ring size. So I'll press apply and press OK. Let's set it, let's link it with the suspension ring offset, not the suspension ring thickness, sorry. So we have a gap which is pretty much close what we need. Now there's a parameter called distance to deck, which is shared parameter, and it is in our shared parameter file. So now we can find the 3 different types of them: distance to deck, and distance to wall. So distance to is just shows the smart hangers that the distance, the custom distance that needs to be written. Distance to deck shows the distance from the center of the duct or of the host element, and it shows the height to the reference level that you want to connect your hanger to. So it can be the distance from the center of the duct to the reference plane. And distance to wall, if we create or insert the support hangers, so it just shows the distance to wall and calculates and writes it in. So for this situation I need a distance to deck parameter, and this one should be grouped in our construction part, and I will make it as an instance parameter, and I'll press OK. So distance to deck shows the height from the center to the reference level. So we need to make the calculation of how high what's the length of our rod should be. So that's we can think about that as if we have the reference level over here and we have the half of diameter height over here. So distance to deck should be the rod length should be suspension ring offset minus the distance to deck and minus the suspension ring offset. So it should be somewhere over here. So to visually evaluate the situation, I'll draw a few reference lines for that. So we should go to the front view, and we'll draw a reference line for that, or reference plane, how you want, depends how you want to see your lines. And then I need to make some annotations. So I need to annotate my center of the ducts, and then the height, the distance to deck height. So now if we'll write the 500 millimeters over here, and we'll set it over here. So we have the distance to deck height. So we need to make our threaded rod the length of equal to this distance to deck. So let's set, okay, so my suspension ring offset is negative parameter, negative count. So I will make a temporary parameter, just for visualization, and I'll make it instance, and this will be minus suspension ring offset. Apply, okay, and I will set it as this parameter over here. So here we have here we have the visual evaluation for length, so we can evaluate very easy. So let's try and count the length of our threaded rod. So now I will go and add parameter. As I said, the parameter will be counted pretty easy. So now the name of parameter will be rod length, for example, and that's right. Let's see if we have that in the share parameter file. Oh yes, we have that, so we can use it, not bothering of creating it. So I'll just insert it here, and then let's calculate the length of it. So first of all, we need our distance to deck. Then we'll minus or plus suspension ring offset, or we can just write diameter divided by half, by 2. And then I'll subtract the suspension ring thickness. So that's about that should be about the height of the rod. So let's press OK and test it out. Let's link it to our rod length and let's make our top extension 0. And let's see, and we can see that that's the accurate calculation. But we have the problem: if we'll make diameter much bigger, we'll get the negative value of our rod length. So we need to calculate we need to flex our family a bit and see what's happening. You can see that diameter of this part doesn't change because we didn't link the parameter to it. So let's try and see what's happening now, so we can see the changes very clearly, and we can see that in some parts we'll get the rod length with the minus value, so we need to calculate that and just write some conditions in. So I'll use the if condition. So if this parameter, if this calculation is less than 5 millimeters, okay, let's make it 10, and then the height will be 10. If not, we'll make it that equal to the calculation we have. And let's try it out. What do we get? So we can see that it works, and our rod length is a little bit higher than the suspension ring. So you won't get to this situation particular situation because it's not logical, but this will make sure that family fluxes correctly and won't cause any problems in the project. So now let's go back and let's insert other parameters for our parts for our hanger, such as webfix purlin. So let's go to the reference level and let's drag our webfix purlin to the view. Let's make sure that it's placed on work plane. And just for starters, I didn't make another thing. It's just I can use this plane over here for our as our work plane. So let's name it as webfix purlin, or distance to deck will be more precise. And we can use it as our reference plane. Just I will set it as my reference plane, and I will insert the webfix purlin here. So I will just rotate it by 180 degrees, and I will lock it to the center. Let's take a look at how it looks like. So the work plane is an extrusion, so I didn't set to use the work plane when I were inserting the webfix purlin, so I then need to reset the work plane for this webfix purlin, and we'll have it in place. So now we can insert the top extension, and you can see that our hanger is almost done. So we need a few more families. We need a washer and a nut to finish off this hanger here. So I'll just insert these families. So I will insert circular plain washer and hexagonal nut. I'll then go to the reference level and I will insert hexagonal nut first. I will place it on work plane, which is distance to deck. That's alright. And there's a lot of different ways to create your own families, and this is just one of the possible ways. So let's take a look in 3D view. That looks pretty good. And now let's go to the reference level, and I'll set my working work plane as the face of this hexagonal nut, and then I will insert the washer. So I think I had to put it on in the opposite way. I will change the planes in a second. Well, let's take a look what we have here. So we have the washer over here. So I'll go to the 3D view and reset all these things right now. So now let's make it a 5:100 offset, and then I will define this as my reference. I will just lock this, and then I will make this as my reference and lock that on top. And let's see what we have in my hidden lines view. So that looks pretty good. And then I will just change my distance to deck parameter. So that didn't change, and we have to find the cause of it. So the offset is 200. If that's 0, then it's okay. So let's see why it happens. So let's write the 500 here, and the offset will be -200. So that's the cause is because I aligned these parts over here, and the webfix purlin is just constrained to these parts over here. So what I need to do is go to the front view and constrain it to my distance to deck reference plane. And let's see what happens now. If we'll change the distance to deck parameter, constraints will not be satisfied, so I will just delete these and check if that works now. So now it does work. So what I will do is just insert these parts again. I will set my reference, the work plane, as distance to deck, and then at first I will insert plane washer, just make sure that the place on work plane is set. Let's make sure that it's on distance to deck, and then let's align it to our reference planes, and let's see in 3D view if that's correct. That is. Then I will go again to the reference level. I'll set my work plane as the face of my circular plane washer, and then I'll insert the hexagonal nut for it. So okay, and I will align it to the center. Let's see what happens in the 3D view. Okay, so I will have to edit the work plane again. And let's test it out if that works now. So that works. So I'll set the top extension parameter for my rod. Let's make it a type parameter. And let's set it to 20, for example. And let's link it. So we have all the hang. So in Revit, the duct coordinate system goes from in X axis. So to visualize it, we can draw a virtual duct on our center front back reference plane. So as we can see that our hanger is built in quite a different way. So if we'll insert that right now, we'll get that our hanger just crosses duct incorrectly. We have a parameter for that, just for showing how our hanger is rotated, and I will just go right now and just insert add another parameter here, which is called family rotated, and that can be a type or instance parameter because we'll set the formula for it, because it's a permanent parameter. So I will make it as a type, and then go to the type of parameter and choose angle, and grouping, we should group it to the construction part. And here we can see we can set the rotation of the family. So if the family rotates from if the family is rotated from x-axis to the top, this is the minus 90 degrees rotation. If it's rotated clockwise to the bottom, it is a plus 90 rotation. So in this particular situation, we have rotation. We've rotated the hanger minus 90 degrees counterclockwise. So we'll enter the minus 90 degrees rotation, and now the smart hangers will know how the family is rotated. I'll press OK, and then I will set some family category and parameters. So smart hangers knows that this is the hanger if it is in structural connections category, and we should make sure that it is a shared family, because we will want that all the instances in this family assembly is visible to Revit project. Another parameter that is very useful is we want to know how what type of hanger it is. So we have another parameter called host category, which we can find in shared parameter file, and we'll just we need to group it to the construction parameters, and we should name it as the category of host element by the native namings of host category of Revit. So it is OST duct curves for duct, and smart hangers then will know what type of the hanger it is. These parameters can be found in template hanger families that is provided with smart hangers, and you can find them over here, or you can use lookup tool that comes with Revit A SDK. So I'll press OK, and I can now load this family to the project and test it out. So I will open up the template project, and we have round duct over here. So I will delete the old families from here, and then I will upload my hanger family to this project. I will use the existing subcomponent family that is in the project, and then I will try to insert the hangers to this duct. So we can see that our family is filtered over here, and I can add it and just set the connection categories, intersection categories, and the family that I want to connect it the hanger to, and just press insert to model to see what happens. So we can see that the hanger works really well as we prefer, and we can make a lot of different modifications to it. For example, if we want that our smart hangers would read information from the structural framing that is connected to. For example, the parameters such as dimensions of the hanger, the height and the width, and so on. These can be written and modified into parameters under the structural category, and these would be written in. So you can use this a lot. And then if you need that your hanger would be offsetted a little bit, so for example our hanger just intersects this structural framing a little bit incorrectly, we want it to be moved, offsetted to the front a little bit. So we should create a reference plane that would be that would that would show where the hanger is. So for example, I'll just make a reference plane, and I would make the annotation for the length between these two reference planes, and just call it the offset, and this offset would work for this particular hanger as the reference to move it a little bit forward. So that's about it, the hanger creation and usage in your projects. There's I made few tricks and tips that would allow user to create their own custom hangers. And for any questions that you have, you can always refer to support at aga-cad.com, and the technical team will be more than happy to answer them for you. Thank you very much.